Welcome, students of math, to Trig Functions Part 3. I've got a question sitting right here, and we're going to slog our way through it and show you how easy it actually is. It reads tan theta equals negative 3.732, and theta is in quadrant 4. Our job is to find sine theta. So let's get a picture. I really think makes the job so much easier if you get a kind of a visual on this. So it says here we're in quadrant 4, so I'm going to draw my terminal arm in quadrant 4. So I'm going to build, now this means theta has come roundy round like this. So there's technically theta, but as we know, the reference angle is related to theta. So I'm going to build up my little right triangle here. Okay. And I'm going to use the other information now. It says tangent of theta equals this negative 3.732. And I'm going to make that a fraction over 1. If I make it a fraction like this, then I can say, oh, tangent, that would be opposite over adjacent. So I can write negative 3.732 over 1. Okay, well, I got two sides of my right triangle. I'm now going to go ahead and use Pythagoras' theorem. So I would go hypotenuse squared equals, and I don't have to worry about the negative here because it's going to get squared anyway. 3.732 squared plus 1 squared. So then I'd work all this out, and it turns out when I punch it all through on the calculator, I get a hypotenuse of 3.8636. So that is now my hypotenuse over here, 3.8636. And you notice I kept quite a few decimal places, and that just keeps the little bit increased accuracy. So I'm totally ready now to figure out what sine theta is. It is opposite over hypotenuse. So negative 3.732 divided by 3.8636. And I wouldn't leave my answer like that. I would put it through in the calculator. Looks a lot better if you just say negative 0.9659. And there it is. So that's all there is to it. Keep in mind, the big thing you want to do is this sketch. Give yourself a guide. And then it was Pythagoras' theorem, and then we just kind of put it together. And voila, there's our answer. So let's move on now to something a little different. Now we're going to look at finding the angle. Okay. So this time there's different clues given, and what we're after is the angle itself. Now typically it's understood when we're looking for the angle, let's call it theta, we're talking about between 0 and 360 degrees. Okay, that's what we're after. We're not talking about coterminal angles that are like 4,012 or something. We want to know the one that's kind of the closest to home, the one that's positive and falls within that first rotation. What would the question look like? Well, let's do an example here. Okay, so it might be something like this. They tell us sine theta equals 0.5, and then they say find theta, okay, or determine theta, okay. So first things first, how do you deal with a trig equation like this? Well, there's a theta in the equation, and we would like to end up with theta equals. So really what I want to get rid of is this sine business. So here's how we do it. We go sine inverse, because a sine inverse undoes what sine did. These are inverse functions, and they kind of kill each other off, leaving only the theta. Now, what you do to one side of your equation, you have to do to the other side. So here's the real work in this question. Okay, because on this side, well, they undo each other, and you're left with theta. On the right side, I have to go sine inverse of 0.5. Now make sure that you are in degrees. There are other measurements for angles. They're not all degrees. So you have to make sure your calculator is in degree mode for this to work. So after you've checked, try sine inverse of 0.5 and you should get 30 degrees. So there's an answer. And you go, hey, that's not bad. However, there's almost always going to be a second answer. Okay, and this is really where the work is, because this part of it was kind of done on the calculator. So here's where the work lies. And I always like to draw the grid and kind of do my thinking on the grid. I'm going to label each quadrant with the cast rule. So I go, yep, C-A-S-T. All right, so now, this original equation was sine theta equals a positive number. Now, for a sine to be positive means I must have been in this quadrant, but I could also be in this quadrant. Okay, so look what the calculator did. The calculator gave us the angle in this quadrant. Said, yeah, it's 30 degrees. There you go. Okay, perfect. But what's the angle going to be in this quadrant? Well, remember when we were analyzing this stuff and we kept building these little right triangles here? Well, these little right triangles were all actually the same size. They were actually identical triangles. So if you build the same triangle over here, try to draw it so it looks reasonable. If I build the same triangle over in this quadrant where the sine is also positive, this would have to be a 30-degree angle. This would be my terminal arm. So I go, okay, so this actually should give us the same sign, but how do we name where we ended up? What you got to do now is go, well, I name it starting here, right? This is my initial arm, and we rotate till we get to there. So what is this angle that we just rotated through? Well, it's 180 minus 30. So the other angle that we want comes from saying, yeah, it's the supplement here. We go 180 minus 30, it's actually 150 degrees. Okay, how could I check my work? This is a really easy way to check. All you do is take your calculator and try it out. Try putting in sine of 150, and you should get positive 0.5. And that's the key. It's got to be positive. All right, so that's how this works. So what I'm going to do is one more example. Clear the screen here. And then we're going to stop there. So this time we're looking for cosine of theta, and it is negative 0.9511. Okay, we're talking again theta between 0 and 360. So the first thing I'm going to do is hit it with cos inverse, both sides. Okay, that undoes the cosine. So I have theta equal. So here on the calculator I punch in cos inverse negative 0.9511. And I get 162 degrees. There's an answer. But I know there should be a second one as well. So let's go to the grid. Whoops. Let's see if I can do a straighter line than that. That was, okay, a little bit better. Okay, so the calculator has given us 162 degrees, which is a little bit shy of 180. So it's something like that. So there it is, 162 degrees. Now if I use the cast rule, I can see which other quadrant I want to be in. So I go, well, this was a cosine that was negative. So I don't want to be here. I do want to be here, but I already knew that. And I do want to be here. So these are the two quadrants where cosine goes negative. So I want to be in this quadrant over here. So I want to build essentially the same little triangle in this quadrant. So this is really what I'm after, is they got to have the same little reference angle. Now you can do this one of two ways. You can determine the reference angle, which turns out to be 18 degrees, and you build it in this triangle here, and then you say, okay, all I got to do is name the angle now. Now it's getting a little messy here, but remember, it starts here, and you'd rotate through the 180, and then you'd go the extra 18. So one way to figure it out is you can say, yeah, it's 180 plus 18. And so that's going to be, looks like 198. Okay, and that works just fine. There is another, often speedier way to do it, though, and that is, if you think of the entire rotation of 360, and then you say, I actually want to back it up by this amount, which is 162, or if you like, negative 162. So I could do a full rotation and then back it up. Guess what? I get exactly the same thing. I wouldn't say there is a better method, but they both work. They both work. And that's where I'm going to stop for now. So we'll catch you later.